Welcome to Easy Math TV. We are talking about patterns between two numbers, more on linear equations, but this is an application. The application is going to be demand, so we're in the area of supply and demand. Our goal today is to write the demand equation in the form of price as a function of quantity, which is different than what we typically see in economics textbooks. We assume the demand equation is linear unless we are told otherwise. So the question that is stated over here says a baseball stadium has a seating capacity of 70,000. When tickets sell for $18, there are 28,000 seats sold. When the price is $15, there are 35,000 seats sold. Write or find the demand equation for price as a function of quantity sold. Okay, so we're using our spreadsheet that we had used before when it came to, like, we were given two ordered pairs and we had to find the equation of a line. So we're just going to use that same sheet. And I wanted you to see this because when there aren't any values plugged in to our x's and y's, you're going to get a lot of errors over here. There's a lot of division by zero. That's fine. That'll get fixed in a moment. We'll see how that gets fixed. And the other thing that we need to note is that one of the hard parts of these kinds of problems is figuring out which quantity is going to be your x and which quantity is going to be your y. So when it comes to business applications, we're going to kind of tend towards almost always choosing the y variable to have to do with dollars. So that's going to be measuring things like cost and revenue and profit eventually. So just default to that. Default to choosing your y values whenever you see a price, whenever you see a dollar amount. That's going to be our y. All right. So I'm going to kind of go down to about in the middle of this table, and that's where we're going to start. So basically, let's start with our x's. So if the y's are price, then the x's are ticket sales. And instead of using the numbers in the thousands, because those zero, we don't need those extra zeros, we're going to start with just the number 28 for x. And then the number below that is 35. So I want you to notice that in my x column, we want those x values to start small and get bigger and bigger and bigger as we go down, because it just makes things easier to read later. So we can just fill down and we can fill up to complete the table. All right, so now we have a bunch of values that we can use. And across from the 28, so that is my 28,000, by the way. 28,000 seats, that's x equals 28. So over here, what was the price at that level of sales? So the price was 18. And reading the problem, when we were able to sell 35,000 seats, the price was 15. So there you see our two x's and our two y's. All right. So I'm going to go ahead and fill that down and also fill up. So, I mean, it's kind of unreasonable to expect that we would be selling tickets for $6 a piece, but you never know, because I mean the seating capacity is 70,000. So even if we were to sell the tickets for $6 a piece, we would still only be selling 56,000 seats. So that is still possible. All right, so we're almost done because our spreadsheet just automatically calculated both our M and our B value. So we're just going to plug those into our equation. The equation is y equals, and we take our slope, which is negative 0. And let's just round that to 0.43, negative 0.43, and multiply that by x. And then we add to that our b value, which is 30. So that is our equation for price based on demand. And so no matter what the value of x is, as long as x is being measured in thousands of tickets sold, we can predict what the price is based on the number of tickets that we sold. So basically, like, even if we just sold, we want to know, what about 45,000? 45,000 is kind of in the middle of two values in our table. So if X is 45, if we want to sell 45,000 tickets, what would the price have to be? That's what the purpose of the equation is. So again, like, subscribe, comment down below if you like these videos. We're going to just keep going. We're going to be doing a whole business math course. Thank you.